Hello everyone. In this lecture we'll see a problem on calculus of complex function. So this problem belongs to construction of analytic function. A problem is if phi plus I times psi represent the complex potential of an electrostatic field where psi is equal to x square minus y square plus x divided by x square plus y square, find the complex potential as a function of the complex variable z and hence determine psi phi. See here, so in this question the complex number they have given in terms of phi plus I times psi. So here always they have taken this phi and psi as what here psi they have given the name as electrostatic field. So psi belongs to nothing but what here electrostatic field and phi is nothing but complex potential. So in terms of word also they will give, or remember complex potential is nothing but real part and here electrostatic field is nothing but what here imaginary part. So psi plus phi, so they have given imaginary part, that is electrostatic field. So we need to get what here a real part, that is nothing but complex potential. So for that we need to check whether the given function is analytic or no first. So solution. So in this solution, so first we'll consider the given psi. So given psi value is psi is equal to x square minus y square plus x divided by x square plus y square. So this given psi we have to differentiate partially with respect to x and y. Differentiate with respect to x and y partially. Okay, so if you differentiate this with respect to x and y partially, what we'll get, we'll see. So first one, psi of x. So partial derivative of this psi with respect to x we have to go. So partial derivative of x square with respect to x is 2x minus partial derivative of y square with respect to x is 0. This plus sign as it is. So here, so we are doing with respect to x means x is in the numerator also, denominator also. So at that time we have to go for u upon v form. So it will become like that. So denominator square, that is x square plus y square whole square. Then keep the numerator as it is, that is x square plus y square. Differentiation of x with respect to x partial is 1, formula minus. Then keep the denominator as it is. Then differentiation of the bracket with respect to x partial is 2x plus 0. So differentiation of x square is 2x, but differentiation of y square with respect to x partial is 0. So on rearrangement, phi of x will become psi of x will become, so this will be 2x plus the simplification of numerator will be, so it is x square plus y square minus, so 2x plus 0 is 2x, so 2x into x is 2x square and this negative sign, so 2x square and divided by x square plus y square as it is, whole square as it is. Now again we need to simplify this, so which is nothing but, so because here x square and minus 2x square will become minus x square will left here. So therefore psi of x is equal to 2x as it is plus, so on simplification we will get here y square minus x square whole divided by x square plus y square whole square. So this is partial derivative of psi with respect to x here. So similarly we need to go for with respect to y now. Now we'll go for with respect to y. So the given function, this psi, we have to differentiate partially with respect to y. So if you differentiate partially with respect to y, at that time x we have to treat as a constant. So what happens, we'll see. So symbolically it will become psi of y is equal to, so partial derivative of x square minus y square with respect to y is x square is 0, y square is minus 2y here. So therefore it will become 0 minus 2y plus, again now you can see here, so partial derivative of x divided by x square plus y square. So x is a constant here, so it is nothing but it is a, means you have to go for differentiation of 1 upon y square. So because here all x are constant, so constant divided by, that is 1 divided by y square, so that derivative we need to apply. So it will become, so because here x square is a constant, this x square is a constant, so the partial derivative will become, or else we'll go for the u by v formula only, better for easiest way. So denominator square, so x square plus y square whole square, so denominator, that is x square plus y square as it is. So partial derivative of x with respect to y is 0, formula minus, then keep x as it is. So partial derivative of this bracket with respect to y partial is 0 plus 2y. So on simplification, psi of y is equal to minus 2y plus, so this 0 into this entire will be 0, so minus x into 0 plus 2y is 2y into this x is what here, so minus sign, so 2xy will get here, divided by x square plus y square whole square, or I will rewrite this psi of y as minus 2y, plus into minus is minus 2xy divided by x square plus y square whole square. So this is a partial derivative of psi with respect to y. So in this way we have to get psi of x and psi of y. Now as per the steps, we know that to get to check the CR equation, so we need to go for what here, with respect to x over with respect to y over now. So as per, we have the formula as, I will show that formula. So now once we get the partial derivative of u or v, so we got imaginary part we got, so we need to apply this formula, that is f dash of z is equal to ux minus I times uy. So this formula, so instead of that imaginary part is nothing but v, so vy plus I times vx will apply directly here, so which is nothing but here we'll get psi of y plus I times psi of x we have to use. So already it is given, so it is manipulated, so I will take directly f dash of z is equal to, instead of v we have to take psi of y plus I times psi of x. So what happens, we'll see here. Now consider f dash of z is equal to psi of y plus I times psi of x. So now, so while we know the psi of y, just now we have taken that derivative as well as psi of x. So in this, while writing here, I will put what here, putting x is equal to z and y is equal to 0. So what happens to psi of y? We'll write, then we'll write psi of x. So let's, what is a psi of y? When you apply x is equal to z and y is equal to 0, we'll see now. If you replace y is equal to 0 means this term will become 0, and this 2x into 0 is 0, 0 upon anything is 0. So psi of y, if you put x is equal to z and y is equal to 0, so this completely will become 0. So therefore psi of y equal to 0 if you put x is equal to z and y is equal to 0. So therefore, so first term will be 0 plus I times psi of x. If you put x is equal to z and y is equal to 0 in psi of x, what happens, we'll see. So in this we need to apply x is equal to z and y is equal to 0. So if you apply x is equal to z, so it will become 2z plus 0 square minus z square divided by z square plus 0 square whole square it will be. So therefore we'll write this one as, so I as it is, so bracket, so it will become 2z plus 0 square, that is y 0 means 0 square, leave it, so it will become minus z square divided by my z square whole square. Okay, if you apply there y is 0 and x is equal to z, you will get psi of x this much. Or so 0, leave it, 0 plus, you leave it, I times, you rearrange this, so it will become 2z plus into minus is minus, z square divided by z square whole square will become z raised to 4. So again on simplification, so this term will become I times 2z minus, so z square, and among this z square cancels, 1 upon z square left here. So this is the term we got now. So for this is nothing but our f dash of z. So but I want f of z. To get f of z we have to integrate on both sides. So on integration, f dash of z will become f of z. I is a constant, integration of 2z minus 1 upon z square into dz plus c. Therefore I is a constant, integration of 2z is nothing but, I will keep outside I, so 2 into integration of z is z square by 2 minus integration of 1 upon z square is nothing but what here, if you take z square up it will become z raised to minus 2. So z raised to minus, integration of z raised to minus 2 is nothing but, on simplification you will get minus times 1 upon z, that minus and this minus will become plus 1 upon z plus c. So again on final conclusion, so 2 cancel, so f of z will be I times z square plus 1 upon z plus c. So this is a required analytic function. Okay, so this is a required analytic function f of z. But as per the required question we want phi value. Phi is nothing but real part. To get real part we have to use again now this f of z, can be written as phi plus I times psi. Okay, then I times bracket, this z I will convert in terms of complex number, that is x plus iy, this square as it is, plus 1 divided by this z I will replace as what here, x plus iy, this plus c as it is. So for information I will put z is equal to x plus iy. So where we are putting this one, so what f of z we got, there we are putting to get what here, the value of phi. Now we'll have to go for the simplification of this now. So what is the simplification? Let's see. I times, so we need to go for a plus b whole square, so it will become x square plus I square y square plus 2ab, that is 2xiy plus this as it is 1 upon x plus iy, this plus c as it is. Now again on simplification, I times x square, this I square is nothing but minus 1, that minus and this plus will become minus y square plus this I will write before, I times 2xy plus 1 upon x plus iy. Again here I times bracket x square minus y square plus I times 2xy plus, here we will rationalize the denominator, so it will become x minus iy divided by x plus iy into x minus iy. If you rationalize the denominator we have to change the sign, so plus, so this bracket, this cancels, we will get back our 1 upon x plus iy again. So I have rationalized the denominator, that is rationalization of this is what here, or conjugate of this is x minus iy, so we have to divide and multiply. So but here you can see that it is a plus b form and a minus b form. A plus b and a minus b nothing but a square minus b square, so I will make the denominator as a square minus b square form. So I times x square minus y square plus I times 2xy plus this x square minus x minus iy divided by a plus b, a minus b, so it will become x square minus I square y square plus c, which is nothing but I times x square minus y square plus I times 2xy plus this x minus iy bracket I will keep as it is. So x square, I square is nothing but minus that minus and this minus will become plus y square plus c. So again now we have to go for the finalization of this, so which is nothing but, so I will just multiply this I to this completely now. So if you multiply, so what happens we'll see. So it will become, so I will make this as a bracket here, so it will become I times x square minus y square, I into I is I square, so I square is nothing but minus sign, so I will write I into I is I square is nothing but minus, that minus into plus is minus 2xy, so I times this completely, I times, I will write this x minus iy divided by x square plus y square plus c. Or again we have to see that we have to separate it here, which is nothing but I times this bracket, that is x square minus y square minus 2xy plus I times, I will separate this x divided by x square plus y square minus I times y divided by x square plus y square. So two term divided by this completely one term actually we have to consider. So x divided by this x square plus y square and minus iy divided by x square by, if you take the LCM we will get back this. So again now you push this I to inside this bracket, so we will get this as I times x square minus y square minus 2xy as it is. If you push this I inside, so it will become I times x divided by x square plus y square. So this I into this I will become I square. I square is nothing but minus that minus and this minus will become plus y divided by x square plus y square and this plus c. Now you can observe here, so left hand side we have phi plus I times psi. So this is real part, so real part is free from I, that is this second term and the last but one term, and imaginary parts are, so where the term with the coefficient of I, so these are the terms of I. So therefore on I will rearrange for this. So real part I will take one side, that is a positive term, so which one will become here, okay, let it be, so minus 2xy plus y divided by x square plus y square, it is a real part. Imaginary parts are plus, I will take I common among these two, so if you take I common, so it will become x square minus y square plus x divided by x square plus y square, this plus c as it is. So you can observe here, so this completely is nothing but real part and this completely nothing but imaginary part. So on equating real and imaginary parts, this is phi plus I times psi. So real part is nothing but, if you compare, so phi is equal to the first term, that is minus 2xy plus y upon x square plus y square, because it is free from I. So phi is equal to minus 2xy plus y divided by x square plus y square. So this is the phi, and if you compare to compare psi value, so psi is nothing but x square minus y square plus x divided by x square plus y square. So if you compare the given question, so this is a given question and we got this phi value. So therefore we have to conclude that the complex potential is, that is phi is equal to minus 2xy plus y divided by x square plus y square. So in this way we need to take a analytic problem. So if they have given real part or imaginary part, we have to go forward here opposite of that. So this is one of the very important question. So based on this application of complex function, so they have taken phi as a complex potential and psi as a electrostatic field. So in this way any kind of example you can solve here.